I'd like to thank the organizers of the committee as well as NIANP for giving Beckman Coulter a chance to present for 10 minutes some of our slides. Dr. Arun, my previous speaker, was telling that he was not an expert in nutrition. Let me extend the bar a little bit further. I am not a veterinarian either. My master's is in medical engineering and I work for Beckman Coulter Life Science. And today we'll be having a 10-minute short session on one of our products and the application that we have in veterinary science. So intellectual property, so the contents that you see are intellectual property of Beckman Coulter. Please do consult us before you make any copies of the slide. We'll be happy to share the slide deck with you. To talk about Beckman, we are actually an 85-year-old company. We are part of a larger organization called Danaher, wherein you would have seen a collaboration with Leica Microsystems, Cytiva, Paul Life Science. There are multiple operating companies operating together. And we form a small part of a larger organization, which is actually a $1.6 billion, $16 billion company. Our role is basically to provide centrifugation solutions, cell sorters, as well as flow cytometers and liquid handling stations to our research customers. So we provide various types of flow cytometers, right from entry level to top end. So you can see few of these instruments are found in this very campus and the next. NDRI basically has a Cytoflex S, which is a 4-laser system. NINP has a 6-laser flagship product, which is actually a 6-laser 21-color instrument. And we can see really good research or phenomenal research that is happening in these two institutions, not to mention the multiple 400 plus installations that we have all across India. So fortunately, we have a very good customer base. Just to give you a crash course on how flow cytometry basically works, this is just a 3-minute slide, which basically tells you on the operations of a flow cytometer. So a flow cytometer basically has 3 parts, which is actually a flow liquid part, whose job is to transport the cell of interest. Then it's got an optical part or the laser system, which will evaluate the contents of the sample or the type of sample it's getting evaluated. And finally, you have an optical part, which will transfer the data and then make it into digital signal. So sample is always in a liquid form. It will be aspirated. So this can be cells, single cell suspensions, or semen samples, or any type of blood samples. So you can see that each of the cells, 30,000 cells per second, will be evaluated. That's the speed in which a flow cytometer basically works. You can see two types of detectors, which is giving you the preliminary data. These are the scatter related activity of the cell. So there is a detector directly in the line of sight of the laser. This kind of gives you the size of the cell. So if the cell size is large, it will give you a larger scatter. And if the cell size is small, it will give you a smaller scatter. So this is similar to how Galileo Galilei discovered sizes of planet. Rather than looking at the cell, it looks at the eclipse. So it sees the shadow and it will tell judgments on what the size of cells are basically is. So when a small cell goes, there is a small pulse that is getting generated. When a large cell goes, there's a large pulse that is getting generated. Based on the size of the pulse or the impedance, you will be able to understand what is the size of the cell. So this is how one of the scatters work. So like I said, the speed in which it works is phenomenal. You can evaluate 30,000 cells a second. But the cells are not hollow. Cells have got lots of cellular content in them. And every time the laser pass, they will not be allowed to pass directly. They will get on the cellular, hit on the cellular organelles, and then they'll scatter. So more complex the cell is, you will have more amount of side scatter. So in case if you try to layer the data that is available from forward and side scatter, like what you see in the animation right now, you'll get from a mixed population of cells, you'll be able to distinguish each type of cells. You'll be able to understand what lymphocytes are. You'll be able to understand what monocytes are and then what granulocytes are. This is basically a blood sample that is getting interpreted using the flow cytometry instrument. So on a nutshell, this is how a flow cytometer works. You can characterize the cell, but not only that, you can go one level further as well. In case if you would want to understand the phenotyping, you can just label the cells with markers. Markers will specifically go and bind to the protein of interest, and once the binding happens, you'll be able to see once the laser interrogates the cell, you can see different expressions of proteins as well. So for the interest of time, I'll just skip one more slide and just quickly tell you on how flow cytometer looks at the cell, or once the binding of the marker, fluorescent conjugated marker, happens to the surface to an instrument, it will basically look like this. You can see how well defined each of the markers are. More the number of lasers, more the number of markers you can detect, and you can basically detect proteins that are present on the membrane, proteins that are present on the cytoplasm, nucleus, and in some cases secretory proteins as well, like interferon gamma, TNF alpha. all these secretory proteins also can be detected. So let me quickly tell you some of the experiments that we've been doing here in these two labs, NDRI and NANP. So these are the major broad applications that you can use flow cytometer for. But when you just pivot from the conventional work, you can also use it for veterinary sciences. You can use it for microbiology studies, food and nutrition studies, and the limits are basically it's basically limitless. Depending on what the scope of your research is, you can tailor your instrument. So I'll show you 3 examples where it's possible. I've got 4 minutes, so in 4 minutes I'll try to cover 3. So let me show you one example of testing, counting or enumerating bacterial cells. So normally when you have to enumerate bacterial cells, you know that it takes around 3-day time, because you have to prepare the plates, make the agar, then count incubate the plates, and then it will take somewhere around 3 days to count the total number of CFUs. Using flow cytometer, you can cover the activity in a matter of hours. To be precise, it's 2 hours. How do we do this? Is we use a technique called two-stage staining, wherein we use 2 dyes. One is propydium iodide, and the second dye is called PI sorry, cytonine. So cytonine will go and bind to all the cells, irrespective of whether they are live or dead. And when after treatment, if you apply PI, what happens is wherever there is gap in the cell wall or wherever the cell wall is damaged, the cytonine will be replaced by PI and they will appear red. So to the flow cytometer, the live and dead cell will appear something like this. So this is cytonine in my x-axis, and I've got PI in my y-axis. So you can see that, as and when I go in my x-axis, my positivity is increasing, though these are all my live cells, and these are all my dead cells. So I've got around 18% dead in this population. 17% live in this population, and close to 60% dead in this population. It's a very rapid technique. Staining will take hardly 20 minutes, and analysis of each tube will take less than a minute. So enumeration will happen very fast. So not only that, you can even understand the viability of the semen. So this is something that we do at NDRI very commonly. So you can detect based on the 2-stage staining technique using 2 dyes, cytonine and cybo14 and propydium iodide. We can make judgments of whether the sperm cells are dead, whether they are morbid, or whether they are live. So since this technique is very rapid, you can complement it with a microscope, and it will give you results with respect to absolute count and percentages. So that's the precision in which the instrument basically works. Not only that, you can do ectosome integrity. So you can see the 4 quadrants in which each of these samples lie. So this is live. You can see the demarcation lower. Live acrosome intact, live acrosome reactive, dead acrosome reactive, and dead acrosome intact. So all these informations can be provided. And to a certain extent, the intracellular calcium levels also could be evaluated, again using the same dye. This is fluoro3 in my x-axis and propydium iodide in my y-axis. Based on the way in which each of these dyes get incorporated, you will be able to understand the levels of calcium expression in these cells as well. So to talk about blood-related activity in animals, currently we are working with certain groups which provides the nature of the blood. So we can see that lymphoma and leukemia, are kind of persistent in pet as well as the animal species. So we're using the instrument. So this is the data from a 21 color instrument that we have, where we've characterized most of the blood groups, blood types that are present. You can find the natural killer cells, B cells, T regulatory cells, and in case there is an expression of overexpression or underexpression of any of these cell types, you will be able to distinguish very easily. So diagnosis of a pet animal becomes very easy. You'll be able to tell what is the nature of a disease or the infection the animal basically has. In case if it's suffering from lymphoma or leukemia or any other, the prognosis becomes very, easy to carry out. So you can use the instrument for multiple other activities as well. You can use it for kinetic assay. You can use it for stem cell detection, cloning, microbiology experiments, immunophenotyping. This is something like bread and butter for the instrument. Also, we are getting into small particle detection, exosomes, microparticles as well. So it's a very small instrument. It's really portable. You can see how compact the instrument is. Since we do not have much time, I'll stop my discussion, and I would really encourage you, in case if you can, be part. If we can invite you the stall that we have, we'll be really happy to have an extended conversation on these topics. Thank you very much. Thank you.
Thank you, Mr. Thank you for your explanation of global security. Now, The nursery is